This is number 1 from page 177, lesson 5.1, graphing cubic functions. The directions said, graph the parent cubic function, f of x equals x cubed, and use the graph to answer each question. We learned that if a function has a degree of 3, it's considered a cubic function. For any cubic function, no matter what type of function it is, no matter what numbers it has, x to the third power is the parent function. When you begin putting numbers before the x or after the x, adding, subtracting, multiplying, dividing, that's when you have transformations. But this is the original function where they all derive from. To help us graph quickly and easily, we're going to create our own XY table to generate some points to plot on our graph. It's going to be a better graph if you have graph paper. The explore part gives you 5 x values that work very well with cubic functions. -2, -1, 0, 1, 2. You could use any x value to help you graph your function, but these 5 values are the best for fitting a cubic function in a small graphing window. So if we were to plug in -2 for x into the function, then that would be remember, whenever you raise a negative number to an exponent, you need to put that negative number in parentheses. Because without it, it's not going to always equal the correct thing. So -2 multiplied 3 times equals -8. So that's the y value corresponding to -2. So we will plot that point eventually on the graph, -2, -8. But continuing on, I'm going to use my mental math. -1 to the third power is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So I'm going to put these points on the graph. I'm going to create my own tick marks to represent the numbers on the graph. So make sure your tick marks are equally spaced apart. 0 is always in the middle. 1, 2 to the right, 1, 2 to the left, and my lowest y value is -8, highest y value is +8, so I'm going to count up 8 and down 8. Hopefully it fits. Remember, positive goes to the right, negative goes to the left, positive goes up, negative goes down. Write your numbers small, right beside the line. -2, -8. Try to keep it as neat as possible. When you're connecting the dots, do not make straight lines because a cubic function is not straight. It doesn't have straight edges, it's curved. So try your best to curve to connect the dots. These dots could continue forever, so I'm going to show that each end has an arrow to show that it keeps going forever. This is a continuous function. Part A, state the function's domain and range. I'm going to put the letter D for domain. The domain is a set of all possible x values from lowest to highest. Well, because this is continuous, it's going to continue going to the left and continue going to the right forever. You can also think about reading domain from left to right. So from left to right, this will continue on forever to the left, forever to the right. Another way to describe that is the x values will include every single possible x value that there is. So if these x values are going to be real numbers, then the domain is all real numbers. Your textbook uses a symbol for all real numbers. It's a capital R, but it's got like extra lines on it that I'm not very good at drawing, so I'm just going to say all real numbers. Same thing for the range. For the domain, I said you read it from left to right, but range is read from bottom to top. Looking at our graph, this will continue going down forever, continue going up forever. So it will include every possible y value that there is. That's a real number. So the range includes all real y values, all real y numbers, all real numbers. You can use that funky symbol if you can draw it, whatever floats your boat. Part B. Identify the function's end behavior. EB for end behavior. End behavior is talking about the ends of the function, like where I put the arrows. Let's talk about the one that's going up. This is considered approaching the right end of the graph because your x values are getting higher and higher, approaching positive infinity. Even though I made this arrow point up, it's really pointing sort of diagonally to the right. This will continue moving to the right forever. So the behavior on the right end as the x values, this arrow means approach, touching. As the x values get higher and higher and higher, as I continue going to the right forever, those x values are going to get higher and higher to the value considered infinity. So as the x values get higher and higher, comma, f of x is the same thing as the y values. F of x is the same thing as the y values. The y values are also going to get higher and higher and higher and higher and higher because it's going to the right and it's going up in a diagonal fashion. The y values will also get bigger and bigger, so they will also approach positive infinity. So as the x's get bigger, the y's get bigger. Now, that's not the only end of the graph. That's just to the right side. We also have something going on the left side of the graph. I know I made the arrow look like it's going down, but think about it as going diagonally. This will forever go to the left and forever go down. My graph is not that pretty. If you would like to use this graphing website, www.desmos.com. That is a really good website for graphing functions, and you can see it better on there. I probably need to put it on my screen so you can see it in this video because my drawing is not that great. But anyway, the y values on the left side are going to continue going down as my x values also go down. So when I'm going to the left, the x values are getting lower and lower and lower. -3, -4, -5, -6. Those values are lower and lower. Well, as my x values are moving lower and lower and I'm going to the left, the y values are also decreasing and getting lower and lower. So I write my end behavior as, on the left end of the graph, as the x values are getting lower and lower or approaching negative infinity, my y values, f of x, will also approach negative y values, get lower and lower, negative infinity. Okay. So, like I said, that website, if you go to desmos.com, www.desmos.com, and you click on this red button that says Start Graphing, and then type in f of x, or you can even put y equals f of x equals x to the third power. If you go down in this bottom corner to the show keypad where it says a to the b power, so I can get an exponent, x to the third power. See, that's how it's supposed to look. I'm not an artist. I couldn't make it look like this, but this is going to forever go to the right and up. I'm dragging this with my mouse, and this can also go down and left forever. It keeps going. Part C. Identify the graph's x and y intercepts. That's where it crosses the x and y axis, where it only crosses at 0, 0 for both. D, identify the intervals where the function has positive values and where it has negative values. The positive values are describing the y values. So when it's talking about interval of positive, it's talking about y values. And the intervals of negative are talking about where are the y values going to be negative. And also, when you're describing an interval, you're only describing for what x values. For what x values will the y values be positive? For what x values will the y values be negative? Oops. So when you write your answer, you're only going to describe the x values for where the y values are positive. Well, look at your graph. The y values are positive when they're above 0. These are your positive y values. Well, for this particular function, the y values are going to be positive on the piece that's going to the right above the x-axis. Well, it starts being positive at 0. Don't think about it as going up. Think about it as going to the right. For what x values will the y values be positive? For every positive x value. For every positive x value, as I continue to the right, the y values are all positive. So it's beginning from 0 to infinity. Or, see, that's interval notation. There are two types of notation you can write your answer in. X values greater than 0. That's called set notation. Either answer is acceptable. Okay. For your negative y values, the interval of where your y values are negative, look at your graph. All your y values are negative below the x-axis. All these y values are negative, and this will continue going on to the left and down forever, where all my x values are negative. So the question is, for what x values will my y values be negative? That's for every possible x value below 0. That means it will continue on forever and ever to the left. Just like when you read domain from left to right, you always read intervals left to right. I know this is a lot of information. You'll get it. Left to right. So from left to right, my y values are negative. From negative infinity and stopping at 0, my y values are negative, beginning when my x values are really, really, really high negative, really low, all the way up to 0. That's where the y values stop being negative and transition to being positive y values. So the 0 is the transition point. Or for every x value that is less than 0. -1 is less than 0. -2 is less than 0. Forever. So it's for every possible x value less than 0. As I said, 0 is a transition point. That's where it transitions from being negative y values, transition to positive y values, transition point. So because 0 is a transition point, I have to put parentheses around the 0, and I'm not going to put that little dash underneath, because at the number 0, the y values cannot be negative nor positive. 0 is neither positive nor negative, so I cannot include 0. It's just greater and less than 0. Part E, identify the intervals where the function is increasing and where it is decreasing. Increasing is describing for what x values are the y values increasing. Decreasing means for what x values are the y values decreasing. Well, this will be the same answer as the intervals of positive and negative. Because increasing, these y values are going up. 1, 8, 27, etc. The y values are increasing when my x values are increasing, beginning at 0. So my y values are increasing for when x is greater than 0, just like my interval of positive. Because at 0 and beyond, the y values are increasing. For decreasing, my y values begin decreasing before the 0. These y values are decreasing. However, we have to write our answer in interval notation where it's from left to right, lowest to highest. So the decrease begins below 0, from negative infinity to 0. Decreasing for every x value less than 0. F, tell whether the function is even, odd, or neither and explain. To test if a function is even, odd, or neither, you plug in negative x for x. So plug in negative x for x to determine if a function is even, odd, or neither. The original function was x cubed, but instead of an x, I'm going to replace it with negative x. In parentheses, please, the cube goes outside parentheses. So replace x in the function with negative x. Well, negative x cubed is multiplying negative x 3 times. Negative x times negative x times negative x. That's 3 times. Well, there are understood coefficients of -1 in front of each x. So you're multiplying -1 times -1 times -1. That's -1. Since it's going to be a coefficient of 1, I'm not going to put the 1. I don't have to put the 1. And remember, when you multiply the same base, you add exponents. X to the 1, x to the 1, x to the 1. That's 3. 1 plus 1 plus 1 is 3. So it's negative x cubed. Okay, the original was positive x cubed. So if your answer is negative of the original, that makes it an odd function. This is negative of the original. If they were the same exact results, that would make it even. So because my plugging in negative x gave me a negative x cubed as opposed to the original positive x cubed, that makes it an odd function. Now, if I ended up with the same exact thing, that would have been an even function. If I had more than one term, that would help me determine neither. Neither would be like a mixture of the two. Like some signs would be the same, some signs would change. But if you have one term, it's either odd or even. If I had multiple terms and one sign changed, one sign didn't, 2 signs changed, 1 didn't, any mixture of one sign changing and another not, that makes it neither even nor odd. Finally, part G. Describe the graph symmetry. That goes with what type of function it is. If it's an odd function, it has odd symmetry. If it's an even function, it has even symmetry. So this has odd symmetry since it's an odd function. When you have an odd function, it has symmetry. Symmetry about the origin. symmetry about the origin. O for odd, O for origin. Now, when functions are even, they have symmetry across the y-axis. I repeat, odd functions have symmetry about the origin. O for odd, O for origin. Even functions have symmetry across the y-axis. Y-axis, even functions. Y-axis, even functions. If a function is neither even nor odd, it will not have symmetry over the y-axis or through the origin. Now let's look at our graph one more time. This has symmetry through the origin, meaning if I took the right half of the function, flipped it over and upside down, it makes a match on the other side. I consider odd functions or odd symmetry as a diagonal formation. On one side of the origin, it makes something to the right, and then on the left side of the origin, it's diagonally to the left. It's difficult to explain odd symmetry. Okay, we'll continue talking more about this mumbo jumbo in future lessons.